All right, this is Honors Algebra 2 Pre-Calc. This last video is going to have 3 challenge problems. So the first two, E7 and P7, are going to involve completing the square with lots of fractions. And then the last one's going to be a natural lead-in to what we're going to do in 5.5. So let's go ahead and do some complete the square problems with lots of fractions. So here, the trick is, I know to ignore the constant, right? Nothing weird there, everything's still totally fine. But then right when I get to the factor out a step, I notice a problem. Normally, this second term is conveniently a multiple of that. So like this second term would be a multiple of 2 and I could factor it out, but here I can't. So when I factor a 2 out, I'm going to end up with a coefficient of 3 halves, like negative 3 halves x, right? And so before I even do my triangle step, I already have a fraction. So now, when I divide this thing by 2, I'm going to get a negative 3/4, because when you divide a fraction, essentially the denominator gets bigger, right? If you divide 3 halves by 2, you get 3/4. So I have this negative 3/4, and then I'm going to square it, which is going to be a plus 9/16. But I didn't really add 9/16, right? Because I added 2 times 9/16, which would actually be a 9/8, right? Because one of the 2's would cancel. So out here, I'm going to subtract 9/8. What that's going to mean is that I get a 2. I use this circled number, so I get an x minus 3/4 quantity squared. And this is one of those problems where it's really obvious why it's beneficial to not have to factor this trinomial out. You could figure it out. You really could. No big deal. But it would be much harder to try and factor that than just to recognize that you've created a perfect square where this circled number is what goes in the parentheses. And then out here, remember that 10, in terms of 8s, would be 88s, right? So this is 88s minus 9/8, which would be a plus 71/8. Good times, lots of fractions, we just completed the square. All right, P7, same deal. So pause me if you want to try it without me. I'm going to ignore that constant, right? So negative 2x and then plus 4 is way off to the side. Now when I go to factor the 3 out, 3 is not a factor of negative 2, so that's going to get a little ugly. So I'm going to get a 3. This will be an x squared minus 2/3 x, leave a space, and then I just have this plus 4 chilling outside, right? So now when I go to do my triangle step and divide this by 2, the one nice thing, this is going to become a negative 2/6, but it's easier to write it as a negative 1/3, which makes a lot of sense because if you have 2/3 and you cut it in half, now you only have 1/3. So when I square it, it's a plus 1/9, but it isn't really a plus 1/9 because it's 3 times 1/9. So what I've actually added is plus 3/9 or plus 1/3. So out here I'm going to subtract 1/3. What that's going to mean is I'm going to get a 3 in parentheses x minus my circled number, which is the 1/3, so x minus 1/3, right? Quantity squared. And then out here, remember that 4 is actually 12/3, so 12/3 minus 1/3 would be plus 11/3. And there you have it, we have completed the square. All right, so now let's do our fun last challenge problem of the section, which is going to conveniently lead us into what we're going to cover in 5.5. So we're going to solve this by completing the square. Don't stress too much about the solve yet, just focus on the completing the square and then we'll talk about how to solve. So let's complete the square with ax squared plus bx plus c, which is tricky because none of them are actual numbers. Okay, so first thing I'm going to do is ignore the constant, right? So I'm going to write this plus c really far away. And it's all technically equal to 0, so we'll just leave it over here. The next thing I'm going to do is factor out the a. But just like we saw in the last 2 examples, when I factor that a out, if this inside term isn't a factor of a, which we can't know because it's a b, we don't know what b is, I'm going to have to write that as b over a times x, right? And out here I still have that plus c and I still have that equals 0. When I do my triangle step, I'm going to divide this by 2, which basically means double the denominator, right? Just like when we divide a half by 2, we get a 4th, right? So this is b over 2a, and when I square it, that's going to give me a b squared over a 4a squared because both the 2 and the a are squared. But keep in mind, I didn't really add b squared over 4a squared because one of the a's is going to cancel. So what I actually added, right, what we actually added was b squared over just a 4a because one of the a's cancels. So out here, I'm going to write, sorry, that's not what I meant. I'm going to write minus, and I meant to write a b, but I wrote a 4. So minus b over 4, b squared over 4a, right? So that's what I'm going to balance with. So what I seem to have is an a in parentheses x plus the b over 2a, quantity squared. And then out here, I seem to have, if you want to combine these, which is probably a good idea so that they're like terms, right? Remember that my c over 1 is actually the same if I want a denominator of 4a as 4ac over 4a, right? So out here, I'm going to get essentially a 4ac minus ab squared all over my 4a equals 0. Okay, so I've now completed the square. Okay, so I did the first part of my job. The square is complete. Great. Now that I've completed the square, I now have to deal with the second half of the instructions, which is solve by completing the square. So in order to do that, I'm actually going to screenshot this guy real quick, and I'm going to go ahead and give us a new page and drag that on so that we can start fresh. Ignore that that is giant. I will make it smaller. Okay, so let's start fresh and actually do the solving, right? So what we need to do now, right? So now we're going to take this thing, and we're now going to solve for x. But because there's only the 1 power of x, we're going to use SADMAP. And again, when we're done with this, I know it doesn't feel that way. Oh, we're beach balling. Okay, sorry. We're going to use SADMAP. All right, so I know it doesn't feel this way, but when we're done with this, you're going to see something that might look vaguely familiar. Okay, so remember, this is my only number, or this is my only variable that I care about. Everybody else behaves like a number. So the first thing I'm going to do is I'm going to do subtraction and addition, which is going to involve moving this entire thing over. So I'm going to have a times this x plus b over 2a quantity squared. And then when I subtract this thing over, essentially what's going to happen is there's two ways to think about it. You can either think about it as a negative in front of this whole thing, which is fine, right, all over 4a. Or you can go ahead and clean that up, which is probably nicer, and I'll put the b squared in front of the negative 4ac all over 4a. So I'm probably going to write it like this, okay? So now I have a times this x plus b over 2a, quantity squared, equals b squared minus 4ac all over a 4a. Okay, next thing I'm going to do is so I did my subtraction and addition. I'm going to do my division and multiplication. I want to solve for x, so I'm going to divide by a. Remember when I divide by a, right, so if I divide this thing by a, that a lands on the denominator. So I'm going to get x plus b over 2a quantity squared equals b squared minus 4ac all over a 4, and now this a is squared because that a lands on the bottom, right? Okay, so now I can deal with my exponent. I'm going to take a square root, right? So I'm going to get x plus b over 2a. But remember, when I take a square root, I need to write plus or minus. So I'm going to have this plus or minus in front of the square root of b squared minus 4ac all over a 4a squared. But the thing I want you to notice is I can split this into two two roots rather. I can make this the square plus or minus square root of b squared minus 4ac on the top, and on the bottom, this is a perfect square. And I don't need the plus or minus on the entire thing because I just need the whole term, the whole thing to net plus or minus, and I put the plus or minus on the top. Well, this is a perfect square, right? This denominator comes out as a 2a, right? And the plus or minus takes care of my concerns about whether something would come out positive or negative. Cool. Let's give ourselves a little more space. So now I recognize that I have a plus b over 2, or sorry, x plus b over 2a equals plus or minus this square root, the b squared minus 4ac, right, on top of a thing that is no longer in the root and is just a 2a. Now the last thing I need to do is deal with what was originally inside these parentheses, which is subtract this b over 2a over. So I'm going to subtract b over 2a. But conveniently, my right-hand side already has a common denominator of 2a. So what I end up with when I do that is x equals negative b over 2a plus or minus this square root of b squared minus 4ac all over 2a. Since they have the same denominator already, I can combine them into one and make this negative b plus or minus the square root of b squared minus 4ac all over 2a. This has a name. It's called the quadratic formula, and it's section 5.5, which is the next thing we're going to cover in this class. So essentially, the quadratic formula, which is a thing that some of you memorized maybe in Algebra 1, maybe in some other class, is somebody going to all the work to complete the square for you and solve a really ugly quadratic, and that's the deal. So there you have it. That's 5.4.